In this lesson, we're going to look at the remainder theorem, and the goal of this lesson is to use the remainder theorem to find function values or to evaluate a polynomial function at specific values. Now, before we go on, remember in the word remainder theorem, you'll see the word remainder. So we're going to come back to that word remainder quite often. Okay, now one other thing I want to mention to you is this. The remainder in synthetic division. So when we looked at the synthetic division process in the previous lesson, the remainder in synthetic division process has an important interpretation. Now when we use synthetic division, so when using synthetic division, remember the divisor was always of the form x minus c. So the remainder theorem is going to involve the idea of synthetic division. And when we did synthetic division, when you use synthetic division in a previous lesson, the divisor was always of this form. Okay? All right, now, before we can actually use the division algorithm, we need to look at the division algorithm. And let's remind ourselves what the division algorithm in a previous lesson stated. So the division algorithm in a previous lesson stated this. If you divide a polynomial, which in this case, remember, was the dividend, by the divisor, d of x, you always had a quotient, q of x, and then you end up with a remainder. So remember, basically you said something like this. You said the divisor divided into the dividend. You had a quotient. You did all this work, and then you ended up with a remainder. Okay? So the division algorithm stated that the dividend divided by the divisor will equal the quotient plus the remainder divided by the divisor, plus the remainder divided by the divisor. Okay? Now, in our case, in the remainder theorem, our divisor is always a linear factor. So my divisor here is going to be x minus c. So I'm just going to go ahead and rewrite d of x with x minus c. So this becomes f of x divided by x minus c is equal to q of x, the quotient, plus the remainder divided by x minus c. Okay? Now, something I need to mention to you. Remember when you actually did the long division? So if I take x minus c and divide into f of x, so the divisor, dividend, and remember we ended up with a quotient, q of x, and we did all this work, we got r of x. So kind of this what we just wrote here. Do you remember that when we checked our answer, the dividend was equal to the divisor times the quotient, so this times this, the divisor times the quotient plus the remainder. Okay? And so I'm going to go ahead and kind of say this. So the dividend, remember, is f of x. So remember the dividend was equal to the divisor times the quotient plus the remainder. Remember all that? Okay, so f of x will equal x minus c times q of x plus r of x. But I want you to notice that the divisor is a linear factor. Okay? And so if we go back to our lesson on synthetic division, I want you to notice something about your remainder. In every case, when we use synthetic division, and remember you can only use synthetic division if you're dividing a polynomial by another polynomial, and that divisor is a linear factor with a coefficient of x being 1. So when we use synthetic division, notice the remainder was always a constant. See, negative 12, the remainder was always a constant. If you keep looking at all the problems we did, notice the remainder was always a constant. See this? So the quotient plus the remainder divided by the divisor. The remainder was always a constant. And so you may ask, well, why is the remainder always a constant? Well, we talked about that in that lesson. So you see your divisor, x minus 3? Remember when you did that long division? When you did the long division? When you did the long division? Remember you stop whenever the degree of the remainder is less than the degree of the divisor. Well, the divisor here, the degree is 1, right? So that means that if this degree is 1, then this degree must be 0. Well, the degree is 0 whenever you have a constant. So the degree of a constant is 0. Right? So that's why. So this, your divisor is a linear factor. So that means that your remainder must be a constant. So in every case, notice, in every case, look right here as well. See, the remainder is a constant. So here's your divisor. It's linear. It has degree 1. So your remainder must be a constant. A constant has degree 0. A constant has degree 0. Okay? So that was an important thing I had to mention to you. So since we know the remainder is a constant, I'm going to go ahead and rewrite R of x as this. So which one are we going to do? So we have this polynomial, and we have x minus c as our divisor. We're going to have a quotient. And instead of having a remainder that's a function, it's just a constant, right? So I'm just going to put r here. So I'm just going to put r. And so I'm going to say this, the remainder r is a, oops, ran out of room, is a constant, when dividing by x minus c. So whenever you're dividing by x minus c, your remainder is always going to be a constant. Okay? All right, now I'm going to go ahead and rewrite this equation right here on another sheet on the next page. Okay, so all I did was I just rewrote what we had here. On another page, on the top of the next page. Okay, now we get into remainder theorem. So listen carefully. What I'm going to do now is I'm going to evaluate f of x at c. Okay, so I'm going to evaluate f of x at c. So you've had enough problems in previous topics to understand what I mean here. So evaluate f of x at c. So what that means is, so this means find f of c. So in other words, this right here means x equal c. Okay, so when I say evaluate a function at c, I want you to find f of c. This is supposed to be c right here, sorry. So find f of c. Okay, so wherever we see the variable x, I'm going to substitute c. So f of c will equal, okay, listen carefully, will equal, so in place of x, I'm going to substitute c. So it'll be c minus c times q of c, right, plus r. Okay, but I want you to notice something. See that factor right here? That's 0 in it. So c minus c is 0. And so this becomes 0 times q of c plus r. But 0 times q of c, that's also 0 in it. So it becomes 0 plus r, and we know 0 plus r is r. So what that means is that f of c is equal to all of these expressions right here. In particular, f of c is equal to r. Remember, r is your remainder. R is the remainder. So when you did synthetic division, when you used synthetic division, this was your remainder. Okay, that was the remainder. So if I want to evaluate a function at C, all I have to do is use synthetic division, and the answer is R, is the remainder. That's all I have to do. And that is what the remainder theorem says. Okay, so let's talk about this again. So whenever you're dividing a polynomial by x minus c, then the value of the polynomial at c is just the remainder. So f of c is the remainder. So that f of c equal r means this. If a polynomial is divided by x minus c, the remainder is the value of the polynomial at c. So if a polynomial is divided by x minus c, and then whenever it's divided by x minus c, remember we can use synthetic division, right? Synthetic division, x minus c. If the divisor is x minus c, we can use synthetic division. So you're going to see this in a little while. The remainder is the value of the polynomial at c. And so now that's the remainder theorem. So let's talk about the remainder theorem. So I'm going to write it right here, remainder theorem. Remainder theorem. Okay, so the remainder theorem says this. If the polynomial f of x is divided by x minus c, then the remainder is f of c. That's all it is. So the remainder theorem. If a polynomial f of x is divided by x minus c, then the remainder is f of c, which equals r. So you can say f of c, which equals r, the remainder. Okay? All right, so let's look at some problems with this, and we'll see how this applies to the problems that you're going to be responsible for. Okay, so let's do number one. So given that f of x is this polynomial, all right, so remember, you have to be dealing with polynomials in order to use the remainder theorem. So given that f of x is x cubed minus 4x squared plus 5x plus 3, use the remainder theorem to find f of 2. Okay? All right, so remember, the remainder theorem says that whenever you're dividing a polynomial by, in this case, x minus 2, then the remainder is going to be f of 2. All right, so basically I can use synthetic division. So what some students do is this. They'll say, okay, well, I can do this just the long way. I can say I'm going to substitute x equal 2 into wherever I see an x. Yes, you can, but remember the direction says use a remainder theorem. So you must use a remainder theorem, okay? All right, so basically you're going to do this. You're going to use you use synthetic division. So you're going to do 2, just like you did before, and you're going to write the coefficients of x on your constant. So the coefficients in descending order. Remember that any missing term you put a 0. So you're going to say 1, -4, 5, and 3. So x cubed, x squared, x, and your constant. Okay? And then you do synthetic division. So you bring down 1, then you multiply. 2 times 1 is 2, and then you add. -2. -4 plus 2 is -2. Then you multiply again. 2 times -2 is -4. Then you add. 5 plus -4 is 1. Then you multiply. 2 times 1 is 2, and then you add. You get 5, and that's your remainder. Okay, so that's your remainder. So what you found is this. So f of 2 is equal to 5. See how quick that was? It was a lot quicker. It was a lot quicker than saying, so don't use this idea, f of 2 equal 2 cubed minus 4 times 2 squared plus 5 times 2 plus 3. Because remember, you must follow directions. Follow directions. Okay? So remember what I'm about to say. If the direction says use the remainder theorem to find f of 2, then I expect to see this. Do not show me this. Is that clear? You get the same answer. You'll get the same answer. Because look, 2 cubed is 8. 2 squared is 4. 4 times negative 4 is a negative 16. 5 times 2 is 10 plus 3. So 8 minus 16 is a negative 8. Negative 8 plus 10 is 2. And 2 plus 3 is 5. So you get the same answer. But you must follow directions. So direction says, I want you to use the remainder theorem because that's what we're studying. We're studying the remainder theorem. Okay? All right. Now, keep in mind, though, that the remainder theorem only applies if you're dealing with polynomials. Okay? So I just want to show you something. If you're given that f of x is 4 divided by 3x minus 1, first of all, that's not a polynomial. This is not a polynomial. So the remainder theorem would not apply. Okay? So if you were asked to find f of 2, then you actually have to do the substitution. You would have to say 4 divided by 3 times 2 minus 1. So that will be 4 divided by, and then 3 times 2 is 6, and 6 minus 1 is 5. So we get 4/5. Okay? So the remainder theorem only applies if you're dealing with polynomials. Okay? This is not a polynomial. This is a rational expression. This is a rational function. All right, so let's get into the problem. So let's look at number 2. All right, so number 2, given that your function is 3x cubed plus 4x squared minus 5x plus 3, find f of negative 4 using the remainder theorem. So according to the remainder theorem, whenever you're evaluating a function, then the value of that function is the remainder. And so using synthetic division, you're going to say negative 4 here. And then you're going to make sure any missing terms, you put zeros. There aren't any here. So and make sure it's in descending order as well. So you get 3, 4, negative 5, and 3. All right, and so let's see what we get. So we bring on the 3. Negative 4 times 3 is negative 12. When we add, you get negative 8. Multiply negative 4 times negative 8 is 32. You add, what's that, 27? Okay, now we have to use a calculator. And then negative 4 times 27 will give us negative 108. And then when I add, I get negative 105. So that's your remainder. So therefore, f of negative 4 is equal to negative 105. Okay? So notice the work. This is what the work looks like. Do not do this by using substitution because that's not what the remainder theorem says. Okay? All right. Okay, let's look at another one, number 3. Okay, so this time f of x is negative x to the 4th plus 3x cubed minus 2x minus 4. And you want to find f of negative 2. I want you to notice, though, there is a missing term. You see the x squared term's missing. So when we use synthetic division, remember you have to put that missing term. So here's our work. So negative 2. And so we get the coefficient here is negative 1, 3, 0. Don't forget the 0. Negative 2 and negative 4. Okay? All right, so we bring on negative 1 first, and then we multiply. Negative 2 times negative 1 is 2. We add, we get 5. Then we multiply. Negative 2 times 5 is negative 10. We add, we get negative 10. We multiply. Negative 2 times negative 10 is 20. We add, we get 18. Negative 2 times 18 is a negative 36. And we add, we get negative 40. So therefore, f of negative 2 is equal to negative 40. Okay? All right, so that was number 3. Okay, so now notice in number 4, sometimes instead of the problem saying using the remainder theorem, it's going to come out and probably just say use synthetic division. Okay, so it means the same thing. So use synthetic division to find f of 3 if your function is x to the 5th minus 2x cubed plus 12. All right, so remember in the process you're thinking of the remainder theorem. So the remainder theorem, so f of 3 is a remainder you get when using synthetic division. That's what it is. So we have 3, and don't forget any missing terms, you got to use zeros. So we get x to the 5th, the coefficient here is 1. We're missing x to the 4th, so I need a 0. X cubed, the coefficient is negative 2. We're missing x, so I need 0. And then our constant's 12. Okay, so we bring on the first term. 3 times 1 is 3. We add, we get 3. 3 times 3 is 9. We add, we get 7. Negative 2 plus 9, 7. 3 times 7 is 21. We add, we get 21. 3 times 21 is 63. And we add, we get 75. So therefore, f of 3 is equal to 75. Okay? So that was number 4. Okay, so number 5, it's written a little bit differently. So it says this. It says use the remainder theorem to evaluate the following function at x equal negative 2. So basically this means right here, this means find f of negative 2. That's what that means. Okay? So whenever it says evaluate at x equal negative 2, so wherever you see the x, you're going to substitute negative 2. But remember, you want to use a remainder theorem. So that's that idea of synthetic division. So you must do that. You must use synthetic division. Okay, so we're going to get negative 2, and then our coefficients. Notice it is in descending order. I have x cubed, x squared, x, and a constant, so I'm not missing any terms. So 3, 8, 5, negative 7. All right, so that's what we get. Bring on the 3, we multiply. Negative 2 times 3 is negative 6. Then we add 8 to negative 6 is 2. Then we multiply. Negative 2 times 2 is negative 4. We add 5 and negative 4 is 1. We multiply. Negative 2 times 1 is negative 2. We add negative 7 plus a negative 2 is a negative 9. So there's your remainder. So therefore the answer is f of negative 2 is negative 9. Okay, there's number 5. Okay, so again, instead of the problem saying use the remainder theorem, it could say just use synthetic division. So use synthetic division to find g of negative 1 if g of x is x to the 6th minus 4x to the 4th plus 3x squared plus 2. All right, so we're going to use synthetic division. So I have negative 1, and then we need our coefficients here. Notice I am missing x to the 5th, and I am missing x cubed. And I am missing x. So there's going to be 3 zeros in this process. So I have coefficient here is 1. I am missing x to the 5th, so I need a 0. X to the 4th, the coefficient is negative 4. X cubed is missing, I need a 0. X squared, the coefficient is 3. X is missing, I need 0, and then the constant. All right, so let's do the process now. Bring down the 1. Negative 1 times 1 is negative 1. We add, we get negative 1. Negative multiply, negative 1 times negative 1 is a positive 1. We add, negative 4 plus 1 is a negative 3. Then we multiply, negative 1 times negative 3 is a positive 3. Then we add, we get 3. Then we multiply, negative 1 times 3 is a negative 3. We add, we get 0. Negative 1 times 0 is 0. We add, we get 0. Negative 1 times 0 is 0. We add, we get 2. So the remainder is 2. So therefore, g of negative 1 is equal to 2. Okay? That's your work. Okay? That's your work. Now, if you want to check this real quickly, remember though, that's the work, right? That's what you have to show. You have to show this. But if you want to just quickly check using a calculator, so to check using calculator, okay, you could substitute. I just want to remind you about that. So g of -1 will be -1 to the 6th minus 4 times -1 to the 4th plus 3 times -1 squared plus 2. And since that's -1, you really don't have to use a calculator, but let's go and do it. So notice, and be careful with your calculator though. So in parentheses, we have -1, close parentheses, raised to the 6th, right? Minus 4 times, in parentheses, -1, raised to the 4th, okay, plus 3 times, in parentheses, -1, squared, raised to the second power, and then plus 2. If I press equal, hopefully I get the answer 2 here. And I get 2. All right, so you can easily check this, but that is not your work you're supposed to show. This is it. Okay, so just keep that in mind. So whenever it says use synthetic division or use the remainder theorem, it does not mean do the substitution. It means use synthetic division. And so therefore, g of -1 will be the remainder, whatever remainder you get. Okay? All right. Number 7. Let's look at number 7. All right, so let's number 7. So it says use synthetic division to evaluate h of x at x equal -3. So remember what this means. So this means find h of -3. That's what that means. So we're going to use synthetic division. We're going to write this a little bit better. Okay, we're going to use synthetic division. Notice I am not missing any terms here. So we're going to say -3, and then the coefficients are 2, 4, -8, and 1. All right, so let's see what we get. Bring on the 2, we multiply. -3 times 2 is -6. We add 4, -6 is -2. Then we multiply. -3 times -2 is a +6. We add. -8 plus 6 is a -2. We multiply. -3 times -2 is a +6. And we add, we get 7. So that's your remainder. So therefore, h of -3 is equal to 7. Notice the work. This is your work. Okay, that's important. This is your work. Okay, this is your answer. All right. Okay, so let's look at number 8, and this will probably be the last one. So use a remainder theorem to find f of 3/2. Yep, I did put a fraction in there. So don't freak out. You are in college algebra. You can handle fractions. All right, so since it says use a remainder theorem, which it could have easily said use synthetic division, we're going to have to use synthetic division. Notice I am missing some terms here, okay? So we're going to have to keep that in mind. So we have 3/2. We have 3/2. All right, the coefficient of x to the 4th is -1. I am missing x cubed, so it is 0. The coefficient of x squared is 3. Coefficient of x is -2. And notice you are missing the constant, so you must put a 0. Okay? You are missing a constant, you must put a 0. All right, so now let's use synthetic division. Bring down the -1. 3/2 times -1 is a -3/2. When I add, now be careful, when you add 0 plus a -3/2 is a -3/2. Okay, now be careful when multiplying fractions. So I have 3/2 times a -3/2, right? So think about it, write it out if you have to. 3/2 times a -3/2. That's going to be 3 times -3 is a -9. 2 times 2 is 4. So that's -9/4. So that goes here. Okay, now be careful with the rest of this. When you're dealing with fractions, you can easily mess up when either multiplying or adding fractions. Okay, 3 and a -9/4. So let's think about this for a moment. I'm going to go ahead and put it right here. 3 plus a -9/4, right? So remember when adding two numbers, when adding two fractions, you must have the same denominator. Notice that 3 I can write as 3 over 1, so the LCD is 4. So I'm going to write two fractions with that denominator. So 3 divided by 1 is equivalent to what fraction with the denominator of 4? That's your question. So since this denominator is 1 and I need a 4, I'm going to have to multiply by 4. Remember that? So it'll be 4 times 3 is 12. So you all agree that 3 is the same as 12 divided by 4? Since these denominators are the same, the numerators must be the same, because 4 times 1, negative 9 times 1, negative 9 times 1 is negative 9. Notice when I add those two fractions now, they have the same denominator. So 3 plus the negative 9 is a positive 3, so you get 3/4. So that's what goes here, 3/4. Now I want to show you something real quick. You could have used your calculator. Again, you know how to do this. You could use your calculator. Notice you're going to say 3 minus 9/4, or 3 plus a negative 9/4, right? Equals, you get a decimal. So remember, 0.75 is 3/4, right? So if you're having a little trouble, remember how to add or subtract fractions with different denominators. Although you need to know how to do this by hand, then quickly use your calculator. You may say, well, I still don't know what 0.75 is as a, or 75/100 is as a fraction. Well, you know, and you should, you really should, but you know you can use your PRB button right here. So you're going to say second PRB. You're going to change it to a fraction. You get 3/4. Okay? All right, then you're going to multiply again now. All right, so let's do the multiplication. I know you don't like this. I know that. 3/4 times 3/2. So 3/2 times 3/4. 3 times 3 is 9. 2 times 4 is 8. So this becomes 9/8. And then you do the process all over again. I know you do not like that. So you're going to say negative 2 plus 9/8. Negative 2 plus 9/8. I'm just going to say this real quick. You're on a test, because since it's timed, you're not going to have to deal with fractions, because I know you could easily mess up with one little part here, and your remainder is incorrect. So I'm not going to do that to you. Your test will look like the previous 7 problems. Okay, so I do want you though to remember how to add fractions with different denominators. So I have negative 2 plus 9/8. That's what you see here. So the LCD is 8. Okay, so you're going to write two fractions with 8 as a denominator. This is 1 and 8 to be an 8, so you're going to say times 8 and then times 8. So 8 times negative 2 is negative 16. Kind of makes sense because negative 16 divided by 8 is negative 2, right? These denominators are the same, so the numerators have to be the same. And so negative 16/8 plus 9/8 is negative, what was that, 7/8? Okay, so that becomes negative 7/8. Now again, use your calculator. Use your calculator. Negative 2 plus 9 divided by 8 equals, okay, so you get this decimal. So changing it to a fraction, you're going to do second PRB and then press equal, and you get negative 7/8. All right. Now, again, you have to multiply now, so let's do the multiplication. 3/2 times negative 7/8. So negative 3 times negative 7 is a negative 21. 2 times 8 is 16. And that goes here. And then when I add these, 0 plus negative 21/16 is negative 21/16. And there's your answer. So f of 3/2 is going to equal negative 21/16. Okay? So I just wanted to do. I just wanted to show you one with a fraction, just in case on my math lab. On my math lab, you have one that's a fraction. Just be careful with your fractions. See, all of these computations you could have easily, very easily, have messed up. So just be careful. You have access to a calculator to help you with these as well. All right, but it is important. It is very important that you remember. You force yourself to go back and review how to add fractions with unlike denominators. All right, guys, that is the lesson on the remainder theorem. So it's very simple. It's a very simple lesson. It is not difficult. And that is it.